Thanks a lot for giving me the chance to talk here. And I think one of the main important things that we have to do now is leaning back and thinking about are all the paradigms that we are thinking of the best way to do it for the next sheet. And therefore, I was calling this talk reflecting on communication paradigms. Sometimes we think for humans can communicate wirelessly. Humans are constantly sensing the parameters, the partners, reacting on the environment. Humans are sensing and detecting disturbances. And humans always check dependability. What is wireless then doing? Wireless is considered as not safe. No active control over dynamic channel quality is done. The environment changes are not reflected, not sensed. The security is ensured after a successful parameter packet is received. Dependability must be time invariant, which is really hard. So as an approach, I would start with rethinking and thinking about learning the environment. So what happens in the environment? According to the time, I skip the details here and go to the first slide. So if we consider coverage maps are really nice, but in general, they are changing. A research, radiohead is missing, fading out, failing, it is blocked, jammed, whatsoever. UEs can sense the position, sense the signal strengths, and also sense many things that are around and to produce the coverage map itself. We have to do dynamic mapping, update via the core and provide it also for other UEs, that other UEs are available to read and see what is in our environment. They don't have to sense it themselves. They can learn from the others. And with this information, we can predict. So the coverage map can be predicted, and so the quality of service can be predicted. As another step, we can influence the channel by using MULTIPATH, which supports communication. And going into this direction, it's one of the approaches is using reconfigure intelligent surfaces. By using single refractions to achieve line of sight, similar line of sight communication, and alternative paths for if line of sight fails. Multiple reflections can be used for replaying packets. Multiple reflections can be used for localization based on time of arrival. So there are many things that we can use with multiple paths which we are controlling. So we control with the reflection or with specific parts on the environment by beamforming, by passive beamforming, by reconfigure intelligent surfaces, for example. The next thing is learn the timing. So what is about? It's not always the same. Things are moving. Moving obstacles, dynamic parameters can be learned. Blocking scenarios can be learned. Time and position, and also embedded intelligence can be used to reduce and predict latency. What do I mean by this? We're communicating, and at the same time, we can do sensing. We are working on OFDM radar, so sending out OFDM pulses and using the reflections as a radar pulse. So we can sense in the same time when we are doing communication. With this, we can learn the environment. We can learn how to approach a situation when pedestrians coming in, how to approach a situation when my communication partner is moving around somewhere and it goes into a whatsoever shadow fading area or something like this. The next thing is very important. Dependability prediction. So if we are doing communication, sometimes communication is very important, sometimes not. If we have here a gripper, we see there's something coming in the feed, and if there is some device sensed, which we expect that the gripper will grip, we have to take care that at this point in time, when we predict deterministically, more or less, that the gripper grips something, we have to ensure the resources to give the quality of service that it allows communication in with this latency. We don't have to provide the low latency communication for all the time. Specifically, if we're going to AVs, if AVs are coming into an area where it might be complicated to navigate or something like this, we see the AV coming. The AV itself can sense, oh, I'm coming now in some area. And then we ensure more resources, for example, or we can deal with the situation. Or even if the situation is that we can, if there's some obstacle coming in and I'm doing critical communication, I have to say, well, now I have to do critical communication. Please get out of my way. Stop whatsoever. Okay. So, and the next thing is apply security. What I mean by this, security we are applying always. Security is not just done at the end of a communication. Security is done during the communication. So I'm addressing physical layer security in this case. I just, in the interest of time, go to this slide where we talk about using channel impulse response as initial shared secret, a shared random vector, using the channel impulse response for generating the key. So the eavesdropper is not able to use it because they have a different channel impulse response. So there are two nice articles out there, one from Winsbrook. They start this, but of course we are really in the beginning of this research. We don't know what quantization is important, what quantization is necessary to have enough redundancy and enough entropy in there to generate the reliable key. This is one of our next research projects we are doing with Gerhard Fetwas with the Packhausen Institute in the next year. And then, of course, proximity. Proximity is very important for communication and secure that we are really talking with the right guy. And if we're always observing where they are, we can have this as a security parameter. For replay attacks, we have seen this always, the keyless entry things. And then I always say, I want to insulate my wireless channel. What does insulation mean in this case? Insulation is here a very important thing, like I want to protect via sensing doing cooperated sensing, cooperation with multiple sensors like visual sensors, video, radar, position sensing, and these things, to watch out whether or not it is fine to do the communication, to do safety relevant communication, and to work with my UE in a way that I'm able to trust it. And of course, jammers. Jammers are also very hard to detect. But if we place around this insulation area, channel surveillance, and do whatsoever RSI localization, which we do, then we can send there the police or just send there someone who asks the people, please switch off your hotspots or something like this. And then technology is there. Combine it for dependability. We have to use this learning the environment, learning the timing behavior, and learning also about the security to combine it to more safety functions. And I call this as a working title, Federated Communication and Sensing, to extend sensing and communication, because it's more than sensing and communication. It's also using other parameters, meta parameters, communication parameters, message parameters, localization parameters, which can be combined and used in the core. And for what reason? Federated sensing and communication can be used for dependability. What we are doing, if we have two communication partners, we can do more than just looking into the channel and seeing, well, it is nice to communicate now. We can also do radar sensing, we can do LiDAR sensing, we can do whatsoever to ensure with safety and security protocols to ensure good communication quality and dependability. And of course, we have to separate important safety critical communication from non-safety critical communication. And I'm drawing here network standards perspective only a 5G core, because as we heard today, we need 5G to develop 6G. And one extension would be, it's also a suggestion, sensing functions, to implement sensing functions in the core, to implement federated communication and sensing function. I know, thank you. I will hear. And I also want to support the output as not just yes or no, it is also a recommendation what to do to have a yes, to have a go. And this is something that the core should do and not the application layer. If we're going like now with these safety functions over to the application layer, then we are lost in latency. We have to do it in the core. And so I just go to these paradigms that I'm rethinking a little bit. It is very important to learn the environment. It is very important to learn the timing. And it's very important to apply these security relevant things to combine it for a dependable, more reliable communication. Yeah, and with this, I just say thank you. And I'm open for discussion. Well, let's start now or later. Yeah.